Okay, so welcome to this short video series covering the subject, the science of behaviour. At this stage, I'm sure that most of you will be wondering, what on earth will this session be about? And more importantly, how will you benefit from the learning here? Well, to answer this question, we first of all have to get back to basics and look at what do we mean exactly by our behaviour. And then we can start a really fascinating journey of self-discovery, because one of the key objectives for this training module is to help you really get to know yourself. What makes you behave the way that you do, and how you can harness this knowledge for a range of different benefits that could be anything from understanding how to manage your stress triggers to how to present your best self if you're going for that big job or important career move. So as we start to unpack the essence of this subject, I'm sure that you'll feel really excited and also start to know yourself a bit better. So let's first of all go back to the science behind the science, so to speak. The study of our behaviour falls into the field of neuroscience. And the role of neuroscience is to explain behaviour in terms of the activities of the brain. How the brain marshals its billions of individual nerve cells to produce behaviour, and how these cells are influenced by the environment. Now, we're born with approximately 300 billion neurons in our brains, and that reduces to approximately 100 billion by the time that we reach adulthood. But everything we do is connected to the brain. It is the control center of our bodies. It controls everything we do, from movement, communication, emotion, thought, response, and of course, behavior. So simply put, if we can develop our understanding of how the brain works, we can learn more about ourselves and how and why we behave the way that we do. And we've learned more about the human brain in the past 20 years than in our entire previous history. In fact, most of the neuroscientists who've ever lived are still alive today. 25 Nobel Prizes have been awarded to neuroscience or neuroscientists in the last 25 years. So it's a really, really big thing. And here's why we've learnt so much more about the brain in the past 20 years than in the last few thousand. There's a number of different ways to measure brain activity, but one of the most advanced is something called an fMRI, which stands for a functional magnetic resonance imaging. Now, an fMRI does what regular MRIs cannot do. It measures activity within the brain instead of structures. And this is based on the principle that active brain areas have increased blood flow and use more oxygen than inactive areas. And it turns out that blood has different magnetic properties depending on whether it's packed with oxygen or most of the oxygen has been used up. Thus, the fMRI scan can see which parts of the brain are sucking up oxygen and are presumably the most active. This basically enables us to map out the areas of the brain that drive or control everything that we do. If we lie in a high-tech fMRI scanner, we can then monitor the parts of the brain that drive different activities. So if we perform different activities such as blinking, laughing, moving our fingers, looking to the left, up and down and to the right, listening to music, etc., the active part of the brain that controls this activity will literally light up. And so with the years of research that have been conducted so far, you can imagine that we've got a pretty good idea which part of the brain performs what function. And this process is called mapping. And the data that exists is sufficient now to be able to literally pinpoint the part of the brain that controls or governs everything that we do. And that's pretty impressive, huh? So when we talk about behavior, it's important to understand that the role that genetics plays, so this is a sort of nature versus nurture argument, and it's estimated that up to 40% of who we are and how we behave is inherited from our parents, with the remaining 60% being determined by 3 key factors. The first factor is our life experiences. And these are the things that happen to us. So all of these experiences influence our behavior. As an example here, imagine growing up in a remote village in the middle of the Amazon rainforest versus growing up in, a big city like New York. All of the consequences of being born in a completely different environment raise many great philosophical discussions, but what is undeniable is that the behaviours of the two humans will be fundamentally different as they grow up. Our developed behaviour is also key here, and this is the pattern of repetition. So if we do something frequently and regularly, the brain learns. If we stop doing or don't do, the brain either does not learn or forgets. So let me prove a point here very quickly. Imagine that you're just about to go down to the bank to cash a cheque to pay for your holiday. But on the way to the bank, you have a rather unfortunate accident and slip over, and you break your hand, the hand that you sign your cheques with. Now, the only way for you to get the cash for your holiday is to reproduce with 100% accuracy your signature. But you have to use your other hand because your writing hand is broken. Practically speaking, it is very, very difficult to write your signature with your non-writing hand. The reason for this is that you don't usually use it, and so there's no pattern of learnt behaviour that you've been able to refer to. Now, your signature is easy with your writing hand because you've done it so many times. You could literally do it with your eyes closed. Now, that's because your brain has learnt and remembered what movements are needed with your hands and fingers to reproduce the same scribble time after time. Another way to look at how our brain develops our patterns of behaviour is to imagine a freshly grown meadow which has about 2 feet of beautiful grass blowing in the breeze. And as you stand in front of it, you decide to take a walk across it. So on the first day, you decide to walk north across the meadow, and you look back. What will you see as you gaze towards the point due south where you started? Yep, you got it. You'd see a small but traceable track where you walked through the grass and depress the grass as you walk through it. Now let's say the next day you start exactly the same place, but instead of walking north, you walk northwest. What do you see when you look back? Well, you'd see another track that has happened to the one the day before. But the one that you did the day before has started to grow over, and therefore the most recent track is more prominent. And the key point here is the more you walk the same track, the more the path becomes permanent. And if you only walk the same track once, then very quickly the meadow will grow back and there will be no trace of your journey. Learnt behaviours follow the same principle. The more we do something, the more it sticks with us. And then we add our third area to the life experiences, which is something called situational behaviour. And this is how we react to things that happen to us on a day-to-day basis. Putting your hand in a fire, as an example. This is a situation with a visible learning response, and you could call this the way that we adapt to what happens to us. So those are the 3 areas that all sort of influence our behaviours. Now, as mentioned earlier, our brains are made up to 300 billion neurons. And these form our neural network, which you could compare to a very, very complex set of pathways. The pathways allow the movement of chemicals and tiny electrical impulses that are like walking the meadow, but multiplied by millions and millions of times. So to continue the analogy of pathways, imagine that all of the chemicals that flow through these pathways in our brains have different shapes and sizes. Some are round, some are square, some are triangular, and that the receptors between 2 neurons only accept triangles, for example. Then some of the chemicals will need to redirect, rather like cars going down a cul-de-sac or a dead end where they've got to turn around or make another route or take a detour. And this is the principle of how electrical impulses and chemicals pass through our brains every second of every day. A lot of science there, but let's just do a quick recap to sort of condense that into some key learning principles. We now know that our brains have billions of neurons, which have chemicals and electrical impulses travelling through the pathways by their billions. And as these chemicals and electrical impulses create a pathway, that is linked to our behaviour. It drives our behaviour. And if this behaviour is repeated, then it starts to become a more substantial pathway that ultimately, with enough repetition, becomes embedded as a learnt behaviour. Okay, so in the next video, we'll look at what are the chemicals and hormones that are produced in the brain and how the level of production of them in our brains influences our behaviours as part of the journey to get to know ourselves a bit better. I look forward to seeing you in the next video. All the best.